Okay, so moving on, part 2 of our double angle section. We're asked to solve the equation in the given interval. Sine of 2x minus the sine of x equals 0. One thing we need to point out, that is a single angle and that's a double angle. We cannot solve this equation because we're talking about two different types of functions. But I can change that double angle to my formula or identity. And by changing that, I will be able to solve that equation now. And so I look at here and I can factor out a sine of x. Is stuff we've done in the other part of the chapter. And once I factor that out, I set that equal to 0, and setting that equal to 0, I add 1 and divide by 2. And then I have to figure out the angles. To find that, I can look at the sine graph and find out when is 0 in that given interval. At 0 and at pi, and again at 2 pi, but I keep forgetting to change that. I'm going to change that to a parenthesis so that we won't include the other angle. Cosine equal 1/2, positive. So I will look at quadrant 1 and I will look at quadrant 4. Draw a triangle in quadrant 1. You should realize that that angle is pi over 3. Draw an angle in quadrant 4. Remember, in quadrant 4, you get the reference angle and then you get the angle. Part B. Again, this is a single angle and that's a double angle. So I need to change one of them, that one. And the cosine of 2 theta, there are 3 different formulas for cosine. You have to pick the right one or the one that's going to help you. Because this one has the sine, I want to choose something with the sine. So I'm going to change that one into again, because this side of the equation has the sine squared as well. So I need to solve that. I'm going to move stuff around, get it equal to 0. So I'm going to subtract 1 over there, and I'm going to add 2 sine squared over there. So when I add 2, it's going to be a positive. And we said we're going to subtract the 1 over here. So now to solve that, a couple ways to do it. You can move the 1 over here and then take the square root of it. I like to factor. So I factored sine theta minus 1, sine theta plus 1. And then I set each one equal to 0. And I have to figure out when it's a sine 1, when is a negative 1. And again, this sine graph that we did, that we memorized, and that we did over and over and over again will help you to figure out pi over 2 here and 3 pi over 2 here. 2 angles. Okay, moving on. This one's going to be a little bit more interesting. Let's see now. I got to change that double angle. And when I change that, because that's a fraction, I need to get rid of that fraction. So I am going to multiply both sides by 1 minus the tangent squared. Both sides. And when I multiply on this side, it's going to get rid of it. It's going to cancel out. And that's why I'm doing it. Which means I'm going to get 2 tan of x, that's the numerator. On this side, I am going to multiply this into here. I'm going to distribute that. 2 tan of x times 1. 2 tan of x times tangent squared is going to give me a tangent cubed of x. So be careful with that. I'm using the distributive property. Now I'm going to move everything over to one side. So I'm going to get it. I'm going to move this over here. And when I move that over here, it's going to be 0. It's going to go away. And this is going to go away as well. So what I'm left with is 0 equal to that. Now to solve this, I could divide both sides by -2. And when you divide by -2, you still get a 0. And when you take the square root of both sides, did I say square root? I'm actually have to take the cube root of both sides, the cube root. Which is 0. So now I have to look at that and figure out when's the tangent 0. Well, tangent graph is 0 here. Oh, and let me draw my asymptote here. It's also 0 at pi. It's 0 at 0 and again at pi. 2 angles. Okay. 3 examples. More homework. 352, 9 through 14 on. Have fun.